Now that we know how to get Direct3D set up, this playlist is about the essential concepts involved in rendering a scene. In later videos we'll look at some code. Let's start by taking an overview of the ideas that we'll talk about in more detail later. So at the most basic level, rendering a scene involves initializing the scene and then running in a loop. Let's look at the same thing in more detail. So initialization involves setting up the scene, and the work that you do there does not depend on properties of the window. So we can do that work once. We only need to do it once, and we can do it at the same time that we do the rest of the window independent setup that we looked at in the last playlist. Setting up the scene includes work such as starting asynchronous tasks to load shaders. It might also involve starting asynchronous tasks to load geometry from files. And run only takes place after those asynchronous tasks are complete. And I've broken run down into creating geometry buffers and then entering an update and render loop, which ideally will run at 60 Hz. So let's take a look at each of these blue boxes in turn. So the window independent setup, some of it's done by the scene base class, and we looked at that work in the previous playlist, and some of the work's done by the derived scene class, and we'll look at the code there in the next video. So now back to the overview. Let's talk about creating geometry buffers. So each mesh creates buffers from its own geometry. We'll talk about what vertex and index buffers are as we go through this playlist. Back to the overview. Now let's talk about the update and render loop. So this loop continues while the window's not closed. Your scene will change over time, and the update function, the first blue box on the left there, is where you'll make those changes to your scene. And then clear involves clearing the render target and the depth and stencil buffers. Then you do the rendering, and then you present, and the call to present will block for as long as necessary to synchronize your calls to a maximum of 60 Hz. So now let's drill into that render box, the render stage. So the work's done by the mesh batches and the meshes inside each mesh batch. The purpose of or rather what a mesh batch is a set of meshes, all of which share the same shaders and input layout, where the input layout is the structure of a vertex. So, and the reason that we batch meshes together like that is to minimize the number of times that we have to set the state of the rendering pipeline. So each mesh batch, first of all, sets its shaders, and it actually attaches the shaders and the input layout to the pipeline. And then for each mesh inside each mesh batch, the mesh sets its primitive topology, which is the way the indices are interpreted. It could be a line list, it could be a triangle list, it could be a triangle strip, and then the mesh attaches its buffers to the pipeline. And then the only remaining work to do is rendering. So the rendering sets the world transform for that mesh, and then it actually performs a draw. And as you can see, most of the function calls are to do with setting the state before actually doing that drawing.